Good afternoon. I'm Dan Riley with the National Weather Service Weather Forecast Office in Houston, Galveston area. I'm here with Nikki Hathaway and Amaryllis Cotto. They're both meteorologists just like me, but they also spend time as hurricane hunters. Nikki with the NOAA unit and Amaryllis with the Air Force, and they're going to talk to us today about what it's like to be a hurricane hunter. So take it away, Nikki.
Thank you, Dan. As Dan said, my name is Nikki Hathaway. I'm a flight director with the NOAA Hurricane Hunters. And with me today,
I'm Amaryllis Cotto, and I'm an ARO, Aerial Reconnaissance Weather Officer for the Air Force Reserve's Hurricane Hunters.
And we're excited to talk to you today. We wanted to start off just with some pretty cool images here, showing how we work together as a team. So what you can see in the bottom image is actually one of our recent outreach events where the NOAA G4 was there with the Air Force C-130. And then we also get together and talk throughout the year prior to the season, making sure we're ready for hurricane season and essentially know what we have coming up and just collaborate over what we can do to make sure we have a good season. With that, we're going to roll right into Amaryllis is going to talk to us a little bit about the Air Force history.
So let's take it back at how it all started. So it actually started on a dare in the middle of World War II when Lieutenant Colonel Joe Duckworth took an AT-6 Texan training aircraft into the eye of a hurricane. Well, it started back in July in 1943 with a group of English and American pilots from an instrument flight school actually in Bryan, Texas. And they gathered over lunch, and the talk that day was they actually had to evacuate their single-engine AT-6 aircraft away from this approaching hurricane. While some of the pilots had combat experience in much bigger airplanes and sarcastically said that the little AT-6 couldn't take much weather. One of the instructors, Lieutenant Colonel Duckworth, defended his airplane, saying that they could fly in any weather, and the other pilots dared him to actually prove this. So Duckworth actually grabbed the only navigator on base, which was Lieutenant Ralph O'Hare, and together they flew into this hurricane. They penetrated the storm at 5,000 to 6,000 feet as it churned just off the coast. They actually found the eye and circled it a few times, then returned home. Shortly after, Lieutenant Colonel Duckworth enticed the base weather officer to join him on another flight. So Lieutenant William Jones Burdick jumped into the aircraft with Duckworth and became officially the first weather officer to fly into a hurricane. Thus was the modern hurricane hunting born. So this is kind of like the image of the T-6 flying. You can see it's very little, and it actually flew into the eye, circled it around, and came right back. So today we actually fly the C-130Js, and you can see the comparison of how little the T-6 is compared to the C-130. Other aircraft have also flown hurricanes, such as the B-17 or the BW-25, but today the Hurricane Air Force hunters actually fly the C-130.
And so essentially, that is the history of the Air Force hurricane hunters and how they came to be. And as time progressed, we've had many other meteorology agencies come together and essentially be what we are today. So here on the slide, you can see the National Hurricane Center in Miami, Florida. They're the ones that are actually building the forecast that then gets passed along to the WFOs or the weather forecast offices across the United States. Today, we're talking with Dan from the National Weather Service office in Houston. And so what they do is they're taking that local data and essentially giving the impacts and the types of things that their local folks need to know. So the National Hurricane Center then passes it along to the the weather forecast officers, like I mentioned, and that's how the forecasts are generated. Now, on the data collection side, me and Amaryllis are out there actually flying into hurricanes, collecting the data that then goes into the forecast models that the National Hurricane Center is actually analyzing. So that's kind of how things work. We're collecting the data that eventually turns into the forecast. So together we're a team, right? And we're here today to talk about the hurricane season to make sure not only are you prepared, but you understand kind of what goes into making a forecast and what are the hurricane hunters actually doing to help provide data to make the best forecast possible. So the image that you're seeing on the screen here is what we call the campfire graphic, right? You can see that red fire kind of poke on up and peak in that early September timeframe. And that's because that's when the peak of hurricane season is. Those months around August, September, and October are when the tropics are essentially the most active. And that follows pretty much in suit with what we've seen in the past few years. I mean, thinking back to Hurricane Harvey that impacted the Houston area just a few years ago, that actually happened in late August. So this is kind of when we expect the peak or the busiest part of the hurricane season to be. Now let's talk a little bit about tropical cyclone structure. So I just want to make sure we're on the same term here. So tropical cyclone is an umbrella term. It essentially classifies things like hurricanes, tropical storms, tropical depressions, all under one big umbrella of tropical cyclone. So cyclone is a very generalized word. And when we're looking at the cyclone structure here, essentially we're chopping through the cyclone as if we're cutting a piece of cake. So you can kind of see down the vertical of what it looks like inside of a tropical cyclone. And so you see the rain bands that surround the strongest rain band, which is the eye wall, which is what the hurricane hunters are known for penetrating through, going straight into the eye. And then once we're inside the eye, it's a little bit more calm. We have blue skies above, the winds drop off. It's almost like a break for those folks that are flying straight through the storm, either on the C-130 or the P-3. So those are the main parts of a tropical cyclone. And it takes a few ingredients to essentially build or make a tropical cyclone or to have them even form. And those ingredients would be things like warm water, rising air. We're going to have thunderstorms, and you have to have the right wind situation to make sure that a tropical cyclone even forms. So there's a lot of complex stuff that goes into a tropical cyclone becoming what we know to be eventually a hurricane. And so what are the forecasters doing, and how are they tracking these hurricanes to better prepare the public? Well, they're looking at a variety of different types of data. They have surface observations, they have satellite, radar, weather balloons that are going from the ground all the way up to the top of the atmosphere. And the forecasters, like Dan and his team, are working together to build that forecast. Well, for hurricanes, they're usually going over areas where there's not much data collection. And that's when me and Amaryllis come in. We're out there flying into the storms, releasing things like drop wind sondes, which we'll talk a little bit about those in a while, collecting radar data, flight level data that then goes into those computer forecast models that the forecasters are interpreting.
So why do we do this? Well, actually, the impact of hurricane hunter data in forecast is quite drastic, up to 30% more accurate according to the National Hurricane Center. The 30% metric sounds great, but what does this actually mean to the public and the government? This is a 4-day forecast track of Hurricane Ivan. And actually, without the hurricane data, large metropolitan areas such as Tampa, St. Pete, Tallahassee, some smaller towns such as Slidell in Louisiana are potentially preparing for the hurricane. Now, this little red circle that is going to appear kind of shows that kind of vague area. So with a typical hurricane warning costing about $192 million, let's just say over $640,000 per mile, could actually be saved by narrowing the warning area. So indirectly, the hurricane hunter's data actually saves lives. Now, not all storms are the same, but how much has the National Hurricane Center forecast improved with our data alongside the advancements of these models? Well, let's compare. To the left, you see Hurricane Katrina 3-day forecast. This was back in 2005. And to the right, we have Hurricane Florence, an actual 5-day forecast back in 2018. And you can clearly see how much narrow and more accurate the cone is today compared to 15 years ago.
So there are 2 hurricane hunter teams that are essentially out there collecting the best data that we can to make sure that we're better putting the best information that we can into those computer models for the forecasters to interpret. So now we're going to talk a little bit about the differences between the NOAA hurricane hunters and the Air Force hurricane hunters, and just go into some of the specifics. So this is an inside look of my hangar in Lakeland, Florida. This is the NOAA Aircraft Operations Center, and you can see we have actually a few more planes that we haven't talked about just yet. We actually have a fleet of 9 aircraft currently, soon to be 11. We have 2 new ones on the way. And together we're a team of approximately 110 people. And there's not just meteorologists on board these planes, obviously. We have pilots that are leading the front. We have actual engineers in the back that are helping collect the data and send out drop wind sondes. And we have mechanics that are working on our planes on a daily basis, and other support staff. So we have tons of different types of jobs and occupations that go into being a team of the NOAA hurricane hunters. And one important thing that people don't realize is, you know, we have to be available to fly 24/7 all year round. So any time of day, we could be out flying either a hurricane or a scientific mission. We're going to focus on our heavy aircraft today. And the first one I'm going to talk about is the G4 jet. And so this is our high flyer. His name is actually Gonzo. The NOAA hurricane hunters do name their aircraft after the Muppets. So this one's Gonzo, and he flies the highest. So he's sailing up around 45,000 feet. And he actually has 2 different types of radar systems on board for us to monitor as flight directors and the pilots to make sure we're going through the weather as safely as possible. And so essentially they're collecting data surrounding the storm. The G4 jet is going to be going all around, not through the hurricane, but all around the hurricane. And we'll look at the flight path here in a little bit. And then we also have our P3s, and our 2 P3s are named Miss Piggy and Kermit. So those are the actual aircraft that are going straight through the eye of the storm, flying at a much lower altitude, usually around 10,000 feet, obviously varying depending on the mission. But they're the ones that are dealing with a lot more of the turbulence, drop wind songs, like Amaryllis will talk to us about here in a little bit. And they're also collecting radar data. The crew is also a little bit bigger. G4 jet runs around 10 people, while the P3 is closer to around 18 to 22. So this is what it would look like if you were sitting inside of one of our P3s. This is a look at the pilot seat. So you can see some of the data and the different types of equipment that they're using to control the aircraft. And then also one of our flight patterns configured there on the bottom part of the screen. Now we'll throw it over to Amaryllis to talk about the drop wind songs.
Well, first, so why do we fly the way we fly? Well, we fly certain patterns in around the storms to gather loads of data and information about the storm back to the National Hurricane Center. So the drop zones actually shown here in the middle, the little figure that's actually dropping down from the eye, specifically are released in the center, and that sends us all the loads of information regarding the storm. We can also obtain the lat and long of the center. The drop zone information includes pressure, wind speed, wind direction, temperature, dew point. And all of this is ingested into the models ran back at National Hurricane Center and are important to understanding the current state of the storm, but it will also allow us to make corrections to the current forecast track as well as the forecast track expected a few days ahead. So this is just a sample kind of showing how the radiosonde looks. This is when it's deployed, so it has a little parachute, and then it has all the important instruments inside of it that's collecting all of the information in the eye.
So depending on the actual mission that we're flying, whether it be the NOAA G4 jet or the NOAA P3 or even the Air Force C-130, there's different amounts of dropsondes that are deployed on each mission. And so these dropsondes are sampling that vertical profile, the opposite of a weather balloon, sampling that vertical profile from the top of the atmosphere when we release it off the plane all the way to the surface of the Earth. And so depending on the pattern that we're flying, for example, you see on this image here, the one on the left is a G4 jet configuration. So you can see it's a lot more spread out, right? It's not just going straight over the storm. We're collecting environmental data all around the storm, and we're dropping dropsondes along the way, picking up flight level data and radar data. And then the image on the right-hand side is our P3, which is going to be more focused to the actual storm itself, also deploying those dropsondes.
So for us, it's quite similar. It's what we call an alpha pattern. This is just an example of a low-level invest where we not only do the dropsondes, but we actually take notes visually of what's going on. And this is, we kind of analyze the sea states to kind of help determine the wind speeds and directions. And this is quite helpful, especially with those more disorganized storms. So you'll see us kind of flying a little bit below at around 500 feet to 1,500 feet above water to kind of grasp visually a better picture of the storm. And the reason why we fly these patterns is because we want to gather wind data from all 4 quadrants. And this will allow us to kind of know each of the speed of each quadrant of the wind speeds. And it'll kind of give us a bigger picture, a better picture of the strength and structure of the wind field of the storm. So it'll allow us to highlight where the most highest speeds or the most dangerous part of the storm is actually occurring at the moment. This is just an example of the alpha pattern that I spoke about earlier. And yeah, that's pretty much it. It looks very simple, but when you're actually flying it, it can get complicated because these storms are moving the entire time. So that's why you see it's more of a alpha pattern, but it's kind of displaced each time because we actually have to keep trying to penetrate the center of the storm following its motion. This is an example of the Hurricane Harvey, which actually is a very historic storm now, and this one actually produced $125 billion in damage, a little over 40 inches of rainfall just within 4 days. So this was the first major hurricane to make landfall since Wilma back in 2005. Now, a lot of people are curious as to, they always are asking, well, are you scared? Like, what happens? Do you get a little jittery when you're like, do you get a lot of turbulence? So this is kind of to show you how much control the pilots actually need to have when they're penetrating that eye wall. Sometimes it's smooth, but other times you have to actually battle through in order for us to actually achieve a full penetration into the center. And this can happen multiple times during a flight. We fly on average 10 hours per mission. So just to show you that this could be very long and multiple penetrations, and you can actually get this kind of turbulence in a storm over and over again. So Nikki here is going to show you a clip of Hurricane Irma when we were actually trying to penetrate the storm. And you can see how hard it is for pilots to kind of have to maintain control. So, you know, our pilots are a special thing. They actually fly thousands and thousands of hours, and they have so much experience. No matter how hard it is or how tricky it is to fly into these storms, we're always in good hands. Once we penetrate that eye wall, this is the beautiful picture that we actually usually see with a good, well-developed hurricane. And this is the classic stadium effect, where you see all just a clear picture inside of the center with those little puffy clouds closer into the surface.
So all the time, you know, we get asked, what do the hurricane hunters do when it's not hurricane season, right? Well, from the NOAA side, we actually have a lot going on, not during the hurricane season. A lot of different scientific missions that we're out there sampling and surveying, and not just involving our heavy aircraft, we have our light aircraft involved as well, like I showed you back inside the hangar. So this is just a few examples. We actually are out there essentially looking at different types of marine life for our scientists on board the aircraft. Our drones, our unmanned aerial systems are out there doing their thing too, collecting data using those systems. And then we also have things like atmospheric rivers, which we're going to talk a little bit about, that we fly during the winter season, which are essentially horizontal hurricanes for the West Coast. So we go out there and sample those as well. Ocean winds, that image there, that's nice and green in the center, that's flying over Ireland, one of our P3s on one of the winter storm projects. And then even things like atmospheric chemistry or snow surveying, flood surveying, things like that. So we have tons of things going on all throughout the year. And now Amaryllis is going to talk a little bit more about the atmospheric river mission.
So now the Air Force hurricane hunters are also flying the atmospheric river during the off season of the hurricane, as well as some winter storms. And why is this important? Well, it's very important because these storms are actually major water producers and are a big threat for the West Coast. And a lot of information and research is being gathered, and it's actually helping all of the river data and all of the drought, and you know, it's really good for our agriculture too. But there's a lot of scientific data coming out of all of these missions. We also do what we call the Chad and the Hat. So the Chad is a Caribbean Hurricane Awareness Tour, and that's for the Caribbean and Atlantic. And then we also do the Hat, which is the Hurricane Awareness Tour, which serves the Gulf and the East Coast. And this is alongside collaboration with National Hurricane Center, as well as the NOAA Hurricane Hunters. So you'll often find just all of us all together in one space, just having fun, showing the people all of our aircrafts and just sharing our love for hurricane hunting and this like awesome missions that we do every year. So if you want to learn more information about us, about each agency, here are the links that you can click and actually go into our websites and gather more information on us, as well as you can always look up our social media platforms, and this includes Facebook, Instagram, Twitter. The Air Force Reserve's Hurricane Hunters, usually when you do a search, you can find us through all of these platforms.
And from the NOAA side, you know, you can follow us on Instagram at FlyNOAA, and for Facebook, the NOAA Hurricane Hunters. So if you're interested, go give us a like and follow our pages. And with that, we'll take any questions, throwing it back over to Dan.
All right, thank you, Nikki and Amaryllis. That was really interesting. Just a little plug, the Hurricane Awareness Tour will hopefully be coming to Houston next year in 2021. It was due to come here this year, but had to be postponed because of the virus. So we did have a couple questions that came in. One question for each of you: how did you become interested in the weather and in hurricanes, in the weather in general and hurricanes specifically? Nikki,
Amaryllis,
you want to go first? Yeah, go ahead, Nikki.
Okay. So I actually fell in love with the weather in 3rd grade. I remember my teacher at the time, she would tell us to bring in our hurricane latitude and longitude points. I grew up in Florida, so that was kind of the thing that we did, right? And so I would turn on the broadcast meteorologist every morning. I'd write down my latitude and longitude points, and I'd go straight into school. And we had a huge map that we would track them. And so that's what we did during the first part of the school year. And I thought it was fascinating how you can see these big, scary looking storms at the time come from the west coast of Africa or the Caribbean and come close to home. And that's where my interest kind of sparked. So from there, I knew I definitely wanted to become a meteorologist, with my hurricanes being the center of my focus. I love them the most. And then went to school and focused on tropical cyclone research for my master's degree. So it's kind of just been what I fell in love with since a young age.
My story was kind of similar. I actually was younger. I was in Miami, Homestead base at the time, and my first experience with weather was Hurricane Andrew. And I was 5 years old at the time. And after that, it was history in the making for me. This is exactly what I wanted to do. I saw the impacts from the ground. It was a Cat 5, so you can just imagine coding wasn't up to par, and just the whole trauma of it actually motivated me to becoming who I am today. Hurricane hunters has always been my main dream. I did the same thing as Nikki, just focused on my bachelor's, my master's, straight into weather and becoming a meteorologist and concentrating on tropical weather. And it was always a delight to work with it and study the science and the knowledge. I would do it all over again if I had a choice. And that's how it started ever since I was 5 years old.
That's awesome. The next question is kind of similar. What advice would you give to someone that maybe is young now that wants to become a hurricane hunter or a meteorologist? Do you have any advice for them? Nikki, you want to start?
Sure. So if you love math and you love science, then it's definitely a great occupation for you. It's a lot of math, a lot of science, especially once you get to college. So if you fall in love with the numbers and the physics behind things and why do things work this way and those type of questions, then it's definitely something you want to continue with as you go into college. In terms of advice, especially as a female meteorologist, in a male-dominated field, just don't be afraid to be different and to go for your dreams, even if you don't see maybe as many females in the positions that you might want to be at. If anything, that should motivate you more and inspire you to maybe be that first of whatever you want to be, whether that be the first female engineer in something or first meteorologist or a flight director like me or whatever it might be. Just don't be afraid of not maybe seeing what you want to see when you're looking ahead into your career path. Just going for it. So live the dream. It's what I'm doing.
Awesome. Amaryllis?
Yeah, so now I think piggyback on what Nikki has said. Also, meteorology and science in general, it's evolving. There's still a lot of new research and new findings going on. So you got to be prepared that the thing that you learned 2 years ago isn't going to be the same thing that you're learning, now today, what you're discovering now. It's always evolving. So my one advice would be diverse. I mean, look at other things. You can be a part of the hurricane hunters, not just as a meteorologist. I mean, while I was doing my bachelor's, I actually did my pilot license. And that's because I knew that I had to have like a plan B. If I couldn't be a hurricane hunter as a meteorologist, then I would be as a pilot. So be diverse, try different things. I did a lot of things in geosciences, oceanography, weather, pilot, air traffic control. So, I think that has been a definite plus for me over the years because it doesn't allow you to focus on just one thing, and you can learn many things within the job, and that is priceless, actually. So yeah, just try different things and see what you like. Maybe you won't like being a meteorologist for the hurricane hunters. Maybe you would like flying or being an engineer or being a navigator. There's all a position within the team.
That's awesome. Well, thanks both of you. That was very interesting. Really makes me want to become a hurricane hunter as well. But we'll see. Maybe some of the younger folks coming up can take advantage of these things. And I encourage everyone to check out the links on the page there. Thanks again. That was really, really interesting. Thank you.
Thank you, Dan, for having us.
Yes, thank you so much.
You bet.